All right, so are you ready to dive deep into some grade 12 chemistry with us?
Let's do it.
I know it can be a little intimidating,
Yeah.
but honestly, I think we can make it not just understandable, but actually kind of fun.
Oh, absolutely.
So to guide us on this journey, we've got this amazing piece by a chemistry professor with over 30 years of experience.
Wow.
And they share some seriously cool tips and tricks to really make chemistry click.
I'm always excited to hear from seasoned educators like that. They have so much wisdom to share.
Totally. And you know what I thought was really interesting? They talk about actually visualizing molecules, like picturing those teeny tiny atoms bonding together.
It's funny you should say that because I was just thinking about how chemistry is all about making those connections, bringing those abstract concepts down to earth.
Yeah, exactly.
Yeah.
And they start by emphasizing the importance of having a strong foundation.
Of course.
It might sound obvious, but they really stress nailing down those core concepts like atomic structure and the periodic table.
Absolutely. That's what we call scaffolding in learning. Each new concept builds upon the one before it. So if you're shaky on atomic structure, it's going to make understanding bonding and chemical reactions that much harder.
Right. You can't build a skyscraper without understanding concrete and steel first.
Exactly. It all starts with the solid foundation.
And speaking of the periodic table, the professor isn't just talking about memorizing it, which, let's be honest, can be a total snooze fest.
Oh, yeah.
They actually dig into how it's an incredibly powerful tool. It reveals all these hidden trends that explain how different elements behave.
That's something I wish someone had explained to me back in high school. I spent hours trying to memorize that whole thing when I should have been focusing on those underlying trends.
Right, so it's more than just a chart.
Exactly. It's a roadmap to understanding the elements.
Okay, I like that. So instead of memorizing it, we should be looking for those patterns and clues.
Precisely. For example, take electronegativity.
Electronegativity.
Yeah, it's all about how strongly an atom attracts electrons when it forms a bond.
Yep.
And this property changes in a very predictable way as you move across and down the periodic table.
So some atoms are like electron magnets, while others are a little less clingy.
Exactly. And understanding those differences is key to predicting how elements will interact and what types of bonds they will form.
Oh, okay, that's starting to make more sense.
Right.
So it's not just about memorizing the elements, but understanding these patterns and how they dictate chemical behavior.
You got it. It's like having a cheat sheet for predicting chemical reactions.
Now, the professor also emphasizes the importance of practice.
Right.
I have to admit, it doesn't always sound super exciting, but they make a really good point about how crucial it is, especially for a subject like chemistry that's all about problem solving.
It's interesting because it's not just about the quantity of practice, but the quality. Sure, doing tons of problems can be helpful, but you have to be strategic about it.
Okay, so what does strategic practice actually look like?
Well, for starters, don't just jump into the hardest problems right away. Start with the basics, get those down pat, and then gradually increase the difficulty. It's also important to vary the types of problems you are tackling. Don't just stick to one formula or concept. Branch out and test your understanding from different angles.
So it's like training for a marathon. You don't start with a 20-mile run on day one. You gradually build up your endurance and tackle different terrains.
That's a great analogy. And just like with marathon training, you'll start to see progress and gain confidence as you go.
All right, so we've got a solid foundation. We're practicing strategically. What's next?
Well, the professor then dives into one of my favorite learning techniques, visualization.
Okay, I have to admit, when I first read that, I was picturing like some new age meditation thing.
Haha, I can see that. But actually, it's about using visual aids to understand complex concepts. For example, instead of just reading about a molecule, you could build a 3D model of it, seeing how those atoms connect, and understanding its shape in space.
Ah, so it's about engaging a different part of your brain, making those abstract concepts more tangible.
Precisely. And different learners respond to different types of visual aids. Some might benefit from drawing diagrams. Others might prefer using computer simulations. The key is to find what works best for you.
That makes sense. It's like some people learn best by listening, others by doing, and some by seeing.
Exactly. We all have our own unique learning styles, and visualization taps into that visual learning pathway. It's a powerful way to make those abstract concepts stick.
Okay, so we've talked about building a solid foundation, practicing strategically, and tapping into the power of visualization.
Yeah, it's all coming together.
But I feel like there's still something missing.
Well, the professor's next point is all about bridging the gap between textbook chemistry and the real world.
Ah, that's what I was thinking. Because let's be honest, sometimes chemistry can feel a little abstract.
Right. It's easy to get caught up in formulas and equations and forget that chemistry is happening all around us all the time.
Exactly.
Hmm.
So how does the professor suggest we make those connections?
Well, they give a couple of classic examples like the chemistry of cooking and how understanding acids and bases can help you decipher those cleaning product labels. But they also encourage you to go beyond those and find connections that resonate with your own interests.
Ooh, I like that. It's like personalized chemistry. So what if our listener is really into, say, music?
Perfect example. We could talk about the chemistry of sound, how different materials vibrate at different frequencies, creating those unique sound waves that our ears pick up. Or, the chemistry of musical instruments, how different metals and alloys affect the tone and timbre of an instrument.
That's so cool. And if our listener's a total sports fanatic,
Well, there's a whole world of chemistry to explore there, too. We could delve into the science of sports drinks, how electrolytes help replenish fluids and minerals lost through sweat, or the chemistry of performance-enhancing drugs, exploring the ethical considerations and the impact on the human body.
okay, those are some really interesting examples. I'm definitely seeing how chemistry goes way beyond the classroom.
Exactly. And the professor makes a really compelling point about how those real-world connections can actually help you understand the more challenging concepts.
Okay, how so?
Well, let's take organic chemistry, for example. It can feel pretty overwhelming at first with all those complex structures and reactions. But if you start to see those molecules as the building blocks of life, things start to click.
So instead of just memorizing formulas, you're understanding how those molecules actually function in living organisms.
Precisely. It's like suddenly those abstract structures have a purpose, a reason for being.
That makes a lot of sense.
Yeah.
It's like learning about the parts of a car engine. It's one thing to memorize the names of the parts, but it's a whole other level of understanding when you see how those parts work together to make the car run.
Exactly. And that's the beauty of connecting chemistry to the real world. It transforms those abstract concepts into something tangible, something relatable.
Okay, so we've talked about the importance of real-world connections, but the professor also stresses the need for what they call conceptual understanding.
Of course.
Can you break that down for us?
This is really the heart of mastering chemistry. It's about going beyond just memorizing facts and formulas and truly understanding the underlying principles. It's like the difference between knowing the steps to a dance and actually feeling the rhythm and expressing yourself through movement.
Okay, that's a great analogy.
Mm-hmm.
So it's not just about following the recipe, it's about understanding why those ingredients work together to create the final dish.
Exactly. And this is especially important when you start dealing with more complex topics like chemical reactions. You need to understand why those reactions happen, what factors influence their rate and equilibrium, and how to predict the products.
So it's about connecting the dots, seeing the big picture, instead of just focusing on isolated facts.
Precisely. And the professor emphasizes that conceptual understanding is what allows you to solve new problems and apply your knowledge in different situations.
That makes sense. Because if you only memorize facts, you're kind of stuck when you encounter something you haven't seen before.
Exactly. But if you understand the underlying concepts, you can reason your way through those unfamiliar challenges. It's like having a mental toolbox equipped with the tools you need to tackle any chemistry problem.
Okay, I'm starting to see how conceptual understanding is really the key to unlocking success in chemistry. It's about building those mental models, those frameworks for understanding how things work.
You got it. It's about moving beyond rote memorization and becoming a true chemist, a critical thinker who can analyze, predict, and solve problems.
And speaking of problem solving, the professor has some really insightful advice about one of the most dreaded aspects of chemistry, those tricky multi-step problems that can leave your head spinning.
Oh, I know exactly what you're talking about. Those problems can feel like a mental marathon.
Exactly. So what's the secret to conquering those chemistry behemoths?
Well, the professor suggests a very specific approach that involves breaking those complex problems down into smaller, more manageable steps.
Okay, that sounds less intimidating already, but how do you actually do that?
Well, the first step is to really understand what the problem is asking. It sounds obvious, but it's easy to get lost in the details and miss the big picture.
So it's like reading the instructions carefully before you start assembling a piece of furniture.
Exactly. You need to identify the key variables, the units, and the desired outcome. Once you have a clear understanding of the goal, you can start planning your attack.
Okay, so once you know what you're aiming for, what's next?
The professor recommends using a technique called dimensional analysis, which sounds fancy, but is actually a really practical tool for keeping track of units and ensuring that your calculations are on the right track.
Wait, hold on. Dimensional analysis? That sounds vaguely familiar, but I can't quite place it.
You've probably used it before without even realizing it. It's all about using conversion factors to cancel out units and arrive at the desired unit for your answer.
Okay, now that you mention it, I think I remember doing something like that in physics.
Exactly. It's a super useful technique for solving all sorts of science problems, especially those involving unit conversions.
So it's like having a built-in error checking system for your calculations.
Precisely. And the professor stresses the importance of practicing dimensional analysis until it becomes second nature.
That makes sense. Because if you're fumbling with units, it's going to make the whole problem-solving process that much harder.
Exactly. Once you have dimensional analysis down, the next step is to identify the relevant formulas or concepts that apply to the problem.
So it's about connecting the dots between the information given and the tools you have at your disposal.
Precisely. And sometimes this might involve looking back at your notes textbook or even online resources to refresh your memory.
That's where good organization comes in handy. If your notes are a jumbled mess, it's going to make it that much harder to find what you need.
Exactly. Which brings us to the professor's next point, the importance of seeking help when you need it.
Yes. They emphasize that it's okay to admit when you're struggling and to reach out for support.
Absolutely. There's this misconception that asking for help is a sign of weakness, but it's actually the opposite. It shows that you're engaged, that you're willing to put in the effort to truly understand the material.
And the professor reminds us that there are so many resources available to help students succeed, from teachers and tutors to online forums and study groups.
Exactly. The key is to not be afraid to utilize those resources. Reach out to your teacher, connect with your classmates, explore online learning platforms. There's a wealth of support out there.
And they encourage students to see these resources not as a crutch, but as a way to empower themselves to become more confident and independent learners.
I love that perspective. It's about building a network of support, a team of people who can help you navigate the challenges and celebrate the triumphs of your chemistry journey.
Okay, that's some really inspiring advice. It's like having a cheer squad rooting for you every step of the way.
Exactly. And speaking of support systems, the professor's next tip is all about the power of study groups.
Yes. They highlight the benefits of explaining concepts to others and learning from your peers.
You know what's great about study groups is that everyone brings different strengths and perspectives. And the act of explaining something to someone else is one of the best ways to solidify your own understanding.
It's like you're teaching the material, which forces you to really think it through and articulate it clearly.
Exactly. And it can also help you identify any gaps in your knowledge or areas where you need further clarification.
Plus, it can make studying way more fun and less intimidating, especially when you're tackling a challenging subject like chemistry.
Absolutely. It creates a supportive environment where you can bounce ideas off each other, work through problems together, and celebrate those aha moments.
It's like having a brainstorming session for your brain.
I love that analogy. And the professor offers some really practical tips for making the most of study groups, like setting clear goals, dividing tasks, and making sure everyone has a chance to participate.
Okay, so it's about being intentional and structured, not just hanging out and hoping osmosis will take over.
Exactly. And the professor also cautions against relying too heavily on others in the group. It's important to come prepared, having done your own work and thought through the material beforehand.
That makes sense. You don't want to just be a passive participant. You want to actively contribute to the learning process.
Absolutely. And the professor emphasizes the importance of respectful communication and active listening.
So it's not just about getting the answers. It's about engaging in a meaningful dialogue with your peers.
You got it. And the professor also encourages students to try explaining concepts to people outside the study group, like family members or friends.
You might still benefit from your impromptu lesson on stoichiometry.
Exactly. The point is, explaining things to others, regardless of their background, can help you solidify your own understanding and identify any areas where you need to review.
That's a great tip. Now, we've talked about the importance of seeking help when you need it, but the professor also stresses the need for self-reliance and effective study habits.
Absolutely. And they offer some really insightful advice on time management and organization, especially when it comes to juggling a busy schedule with the demands of grade 12 chemistry.
Okay, time management is definitely something I could use some help with. So, what are the professor's golden nuggets of wisdom?
Well, they start by emphasizing the importance of creating a realistic study schedule that takes into account your other commitments, like extracurricular activities, part-time jobs, and, having a life outside of school.
That sounds reasonable, because let's be honest, trying to cram everything into the night before an exam is a recipe for disaster.
Exactly. The professor suggests breaking down large tasks into smaller, more manageable chunks and spacing out study sessions over time to avoid feeling overwhelmed.
So it's like training for a marathon again.
Ex-
Consistent effort over time is key.
Precisely. And they also recommend setting aside dedicated study time in a distraction-free environment.
Ah, yes. That means silencing those notifications, putting away the phone, and resisting the urge to check social media every 5 seconds.
Exactly. It's about creating a space where you can focus solely on the task at hand.
And they also emphasize the importance of active learning, not just passively reading through your notes or textbook.
You know, this is something I'm really passionate about passive learning, is like trying to fill a leaky bucket. You might absorb some information, but a lot of it just spills out. Active learning, on the other hand, is about engaging with the material, asking questions, making connections, and testing your understanding.
Okay, so what are some examples of active learning techniques?
Well, there are so many. You could try summarizing key concepts in your own words, creating flashcards, teaching the material to someone else, or even coming up with your own practice problems.
Those are great ideas. It's about turning learning into an interactive experience, not just a passive absorption of facts.
Yeah, exactly. And the professor also stresses the importance of regular review and self-assessment.
So it's not enough to just learn the material once you need to revisit it periodically to make sure it sticks.
Precisely. They suggest scheduling regular review sessions throughout the semester, not just before exams.
Okay, that makes sense. It's like reinforcing those neural pathways, building those connections in your brain.
Exactly. And they also recommend using practice quizzes or past exams to gauge your understanding and identify any areas where you need to focus your study efforts.
That's a great strategy. It's like taking a practice test before the big game, helping you identify your strengths and weaknesses.
Precisely. And the professor's final piece of advice on study habits is all about taking care of yourself both physically and mentally.
Ah, yes. They emphasize the importance of sleep, nutrition, exercise, and stress management.
You know, it's easy to neglect those things when you're caught up in the academic whirlwind, but they're absolutely essential for optimal learning and performance.
It's like trying to run a car on an empty tank. You need to fuel your body and mind to keep them running smoothly.
That's a great analogy. And the professor reminds us that taking breaks and engaging in activities you enjoy is not a luxury, it's a necessity.
Okay, so it's not about burning yourself out. It's about finding a sustainable pace that allows you to learn effectively without sacrificing your well-being.
Exactly. It's about finding that balance between academic rigor and self-care.
Okay, we've covered a lot of ground in this deep dive into grade 12 chemistry. From building a solid foundation and practicing strategically to connecting chemistry to the real world and mastering the art of problem solving, we've explored a wealth of insights and strategies.
And we've also delved into the importance of conceptual understanding, active learning, seeking help when needed, and taking care of yourself throughout the learning journey.
Wow, I feel like I've just completed a crash course in chemistry success. But wait, there's one more piece of the puzzle we haven't touched on yet. The professor's advice on staying organized.
Yes. This is one of my favorite topics because let's be honest, organization can make or break your success in any subject, but especially in a fast-paced, information-heavy course like grade 12 chemistry.
Okay, so what are the professor's top tips for keeping those chemistry chaos at bay?
Well, they start by emphasizing the importance of having a dedicated study space that's free from distractions and equipped with all the essential tools you need. Textbooks, notes, calculators, periodic tables, the whole shebang.
So it's about creating your own personal chemistry command center.
Exactly. A place where you can focus and immerse yourself in the world of atoms and molecules.
Okay, so once you have your study sanctuary set up, what's next?
The professor then dives into the nitty-gritty of note-taking, which can be a real game changer when it comes to understanding and retaining information.
You know, note-taking is something I've always struggled with. I tend to either write down everything, which is super overwhelming, or miss important details because I'm trying to be too concise.
I understand completely. It's a delicate balance.
Yeah.
But the professor offers some really practical advice, like focusing on key concepts and definitions, using abbreviations and symbols to save time and space, and incorporating visual aids like diagrams and charts to break up large blocks of text.
Okay, so it's about being strategic and creating notes that are both comprehensive and easy to navigate.
Exactly. And they also emphasize the importance of reviewing and organizing your notes regularly. It's not enough to just scribble them down and forget about them.
So it's like keeping your chemistry knowledge tidy and accessible.
Precisely. And the professor suggests using different techniques for organizing notes, like color coding, creating outlines or mind maps, or even using digital note-taking apps that allow you to search and categorize information.
Those are some great tips. It's about finding a system that works for you and helps you make sense of all the information you're learning.
Exactly. And the professor's final piece of advice on organization is all about keeping track of assignments, deadlines, and upcoming exams.
Yes. That can be a real juggling act, especially when you have multiple classes and extracurricular activities vying for your attention.
Absolutely. But the professor suggests using a planner or calendar to schedule study time track assignments and set reminders for upcoming deadlines.
Okay, so it's about being proactive and staying ahead of the game instead of scrambling at the last minute.
Precisely.
Yeah.
And they also recommend breaking down large assignments into smaller, more manageable tasks to avoid feeling overwhelmed.
That's a great strategy. It's like tackling a big project one step at a time instead of trying to climb the whole mountain in a single leap.
Exactly. And the professor emphasizes the importance of seeking clarification from your teacher if you're unsure about an assignment or deadline.
Okay, so it's about advocating for yourself and making sure you're on the right track.
Precisely. And remember, staying organized isn't just about reducing stress and avoiding those last-minute panics. It's also about creating a sense of clarity and control over your learning experience.
That's a great point. It's like having a roadmap for your chemistry journey, guiding you towards success.
Exactly. And with the right tools and strategies, you can navigate the challenges of grade 12 chemistry with confidence and achieve your academic goals.
Okay, so we've explored a ton of valuable advice from this seasoned chemistry professor. But before we wrap up, I'm curious to hear your perspective as an expert. What are some of the most common misconceptions or challenges you see students facing in grade 12 chemistry, and how can they overcome those hurdles?
Well, that's a great question. You know, one of the biggest misconceptions I see is the idea that chemistry is all about memorization, that it's a dry and tedious subject filled with formulas and equations that have no relevance to the real world. And that misconception can really hinder students' motivation and engagement.
Right, because who wants to spend hours memorizing stuff they don't understand or see the point of?
Exactly. So it's crucial to challenge that misconception and help students see chemistry as a dynamic and fascinating field that's all around them, from the food they eat, to the air they breathe, to the technology they use.
Okay, so it's about bringing chemistry to life, making it relatable and relevant to their everyday experiences.
Precisely. And once students start to see those connections, their curiosity and motivation naturally increase.
That makes sense. It's like suddenly those abstract concepts have a purpose, a reason for being.
Exactly. And another common challenge I see is the fear of asking for help, the feeling that they should just get it on their own.
Yes. That can be a real barrier to learning, especially in a challenging subject like chemistry.
Absolutely. So it's crucial to create a supportive learning environment where students feel comfortable asking questions, admitting when they're struggling, and seeking help from their teachers, peers, or online resources.
Okay, so it's about fostering a culture of collaboration and support, where asking for help is seen as a sign of strength, not weakness.
Precisely. And another challenge I often see is the struggle to manage time effectively, especially when students are juggling multiple classes, extracurricular activities, and social lives.
Right, it's a delicate balancing act, and it's easy to feel overwhelmed and let things slip.
Absolutely. So it's crucial to equip students with effective time management strategies, such as creating realistic schedules, prioritizing tasks, breaking down large projects into smaller chunks, and using tools like planners and calendars to stay organized.
Okay, so it's about empowering students to take control of their time and create a system that works for them.
Exactly. And another challenge I see is the tendency to focus on rote memorization instead of conceptual understanding.
Yes. That's a classic trap. But as we've discussed, true mastery of chemistry goes beyond just memorizing facts and formulas.
Exactly. So it's crucial to encourage students to go deeper, to ask why and how questions, and to seek out those underlying principles that connect the dots.
Okay, so it's about fostering a culture of curiosity and critical thinking, where students aren't just passive recipients of information, but active learners who are constantly questioning, exploring, and making connections.
Precisely. And finally, another challenge I often see is the lack of confidence, the feeling that they're just not good at chemistry.
Yes. That can be such a self-limiting belief, especially when it's reinforced by negative experiences or comparisons to others.
Absolutely. So it's crucial to build students' confidence by celebrating their successes no matter how small, by providing them with opportunities to showcase their understanding, and by emphasizing that everyone learns at their own pace and that mistakes are an essential part of the learning process.
Okay, so it's about creating a growth mindset where students believe in their ability to learn and improve regardless of their starting point.
Exactly. And when students have that confidence, they're more likely to persevere through challenges, embrace new learning opportunities, and achieve their full potential in chemistry.
Wow, those are some incredibly valuable insights. Thank you so much for sharing your expertise and for shedding light on those common misconceptions and challenges.
You're very welcome. It's been a pleasure diving deep into these topics with you.
I feel like we've covered a ton of ground in this episode. We've explored the foundations of grade 12 chemistry, delved into strategic study habits, and even tackled those tricky multi-step problems.
And we've also emphasized the importance of connecting chemistry to the real world, fostering conceptual understanding, seeking help when needed, and staying organized.
Phew, that's a lot to process. But I think the key takeaway here is that grade 12 chemistry, while challenging, is definitely achievable with the right approach and mindset.
Absolutely. And I have no doubt that our listener out there, armed with all these insights and strategies, is well on their way to conquering those chemistry challenges and unlocking the wonders of this fascinating field.
That's a great note to end on. So stay tuned for part 2, where we'll continue our exploration of grade 12 chemistry and uncover even more tips and strategies for success. All right, so we're back and ready to keep going with this grade 12 chemistry deep dive.
Yeah, let's jump right back in.
Okay, so before the break, we were talking about some of those misconceptions students often have about chemistry.
Right, like the idea that it's all about memorization.
Yeah, and that it's just a bunch of dry formulas and equations.
Exactly, but we know that's not true.
So how can we help students see chemistry as this fascinating and dynamic field that's all around them?
Well, I think one of the most important things is to connect chemistry to the real world, to show students how it applies to their everyday lives.
Right. Because when you can see how chemistry is relevant to you personally, it becomes much more interesting and engaging.
Exactly. For example, you could talk about the chemistry of cooking or the chemistry of sports drinks or the chemistry of music.
I like that. It's all about making those connections, bringing those abstract concepts down to earth.
Precisely. And once students start to see those connections, their curiosity and motivation naturally increase.
That makes sense. It's like suddenly those abstract concepts have a purpose, a reason for being.
Exactly. And another important thing is to address the fear of asking for help.
Ah, yes. That can be a real barrier to learning, especially in a challenging subject like chemistry.
Absolutely. Students need to know that it's okay to ask questions, to admit when they're struggling, and to seek help from their teachers, peers, or online resources.
Right. It's about creating a supportive learning environment where asking for help is seen as a sign of strength, not weakness.
Exactly. Because when students feel comfortable asking for help, they're more likely to succeed.
And speaking of succeeding, time management is another crucial factor in grade 12 chemistry.
Oh, absolutely. It's so important for students to develop effective time management strategies.
Like creating realistic schedules, prioritizing tasks, and using tools like planners and calendars.
Exactly, because when you're organized and you have a plan, you're less likely to feel overwhelmed and stressed.
And another thing that can really help is to focus on conceptual understanding rather than rote memorization.
You know, that's something I'm really passionate about, because when you understand the concepts, you can apply your knowledge to new situations and solve problems more effectively.
Right. It's about seeing the big picture, making connections, and developing a deep understanding of the material.
Exactly. And finally, I think it's important to address the issue of confidence.
Ah, yes. That can be a big hurdle for many students.
Absolutely. Students need to believe in themselves and their ability to learn and succeed.
So how can we help them build that confidence?
Well, we can celebrate their successes no matter how small, provide them with opportunities to showcase their understanding, and emphasize that everyone learns at their own pace.
Right. It's about creating a growth mindset where students believe that they can improve with effort and perseverance.
Exactly. And when students have that confidence, they're more likely to take risks, ask questions, and push themselves further.
Okay, so we've talked about connecting chemistry to the real world, fostering a supportive learning environment, emphasizing conceptual understanding, promoting effective time management, and building confidence.
Yeah, those are some key strategies for success in grade 12 chemistry.
And now I'd like to shift gears a bit and explore another important aspect of learning the power of mistakes.
Mistakes.
Yeah, because let's be honest, everyone makes mistakes, especially when they're learning something new.
That's so true. But sometimes students can get really discouraged when they make mistakes.
Right, they might feel like they're not smart enough or that they're not cut out for chemistry.
Exactly. But it's important to reframe those mistakes as opportunities for learning and growth.
Okay, so how can we help students see mistakes in a more positive light?
Well, first of all, we need to normalize mistakes. We need to create a culture where it's okay to make mistakes and where students feel safe to take risks and try new things.
Right, because if you're too afraid of making a mistake, you're not going to learn as much.
Exactly. And second, we need to help students learn from their mistakes.
So instead of just getting frustrated or giving up, They should analyze their mistakes and figure out what went wrong.
Precisely. And this is where feedback comes in. Students need to receive constructive feedback that helps them understand why they made a mistake and how to avoid making it again.
Right. It's about turning those mistakes into valuable learning experiences.
Exactly. And finally, I think it's important to celebrate the process of learning, not just the outcome.
So it's not just about getting the right answer. It's about the journey of discovery, the challenges overcome, and the growth achieved along the way.
Exactly. Because when students focus on the process, they're more likely to stay motivated, engaged, and resilient even when they encounter setbacks.
And speaking of setbacks, the professor also offers some really helpful advice on how to deal with those moments of frustration and self-doubt that inevitably arise when you're tackling a challenging subject like chemistry.
Yeah, those moments can be tough, but the professor emphasizes the importance of perseverance, of not giving up even when things get tough.
Right, because let's face it, chemistry isn't always easy. It requires effort, dedication, and a willingness to keep pushing forward even when you encounter obstacles.
Exactly. And the professor suggests a few strategies for developing that perseverance, like setting realistic goals, breaking down large tasks into smaller chunks, and focusing on your progress rather than your shortcomings.
I like that. It's about celebrating those small victories along the way and remembering how far you've come.
Precisely. And they also emphasize the importance of seeking support from others, whether it's your teacher, your classmates, your family, or your friends.
Right, because sometimes just talking to someone about your struggles can make a world of difference.
Absolutely. And finally, the professor reminds us that learning is a lifelong journey. It's not a race to the finish line.
So it's okay to take your time to explore different approaches and to find what works best for you.
Exactly. And the more you learn, the more you realize how much more there is to learn.
That's a great point. It's about cultivating a love of learning, a thirst for knowledge that will stay with you long after you've finished grade 12 chemistry.
Absolutely. And that's something that we can all strive for.
So we've talked about embracing mistakes, developing perseverance, and cultivating a love of learning.
Those are some really important mindset shifts that can make a big difference in a student's chemistry journey.
But now I'd like to bring it back to the practical side of things and talk about one of the most essential tools for success in chemistry, the periodic table.
Yes, the periodic table. That iconic chart that hangs in every chemistry classroom.
Exactly. And the professor emphasizes that it's not just a random collection of elements. It's actually a beautifully organized system that reveals a wealth of information about the properties and behavior of atoms.
It's like a cheat sheet for understanding the building blocks of the universe.
Okay, I like that. So how can we help students see the periodic table as more than just a chart to memorize?
Well, one way is to highlight the trends that exist within the periodic table.
Trends.
Yeah. For example, as you move across a period from left to right, the atomic radius decreases.
Okay, why is that?
Because the number of protons in the nucleus increases, which pulls the electrons in more tightly.
That makes sense. So the atoms get smaller as you go across.
Exactly. And another trend is that as you move down a group, the electronegativity decreases.
Remind me what electronegativity is again.
It's a measure of an atom's ability to attract electrons in a chemical bond.
Right, so the higher the electronegativity, the more strongly an atom pulls on electrons.
Exactly. And as you move down a group, the atoms get larger and the outermost electrons are farther from the nucleus, so they're less attracted to other atoms.
So the atoms at the bottom of the periodic table are kind of like those electron magnets we were talking about earlier, but a bit weaker.
Exactly. And these trends are just the tip of the iceberg. There's so much information encoded in the periodic table, and understanding these trends can help students make predictions about the properties and behavior of elements.
It's like having a secret decoder ring for the elements.
I love that analogy. It really captures the power of the periodic table.
Okay, so we've talked about the importance of understanding the trends in the periodic table.
Yeah, it's a crucial part of mastering chemistry.
But now I'd like to touch on one more topic that can be particularly challenging for grade 12 chemistry students. Chemical reactions.
Chemical reactions.
Yeah, those processes that involve the rearrangement of atoms and the formation of new substances.
Right. And the professor offers some really helpful advice on how to approach these reactions systematically and with confidence.
Okay, so what's the first step?
Well, the professor emphasizes the importance of balancing chemical equations.
Balancing equations.
Yeah, it's all about making sure that the number of atoms of each element is the same on both sides of the equation.
Okay, that sounds important. But why is it necessary?
Because it reflects the law of conservation of mass, which states that matter cannot be created or destroyed in a chemical reaction.
So the atoms are just rearranging themselves, not disappearing or appearing out of thin air.
Exactly. And balancing equations can be a bit tricky at first, but with practice, it becomes second nature.
Okay, so once you have a balanced equation, what's next?
The professor recommends identifying the type of reaction that's occurring.
Type of reaction.
Yeah. There are several different types of reactions, such as synthesis decomposition, single replacement, double replacement, and combustion.
And each type of reaction has its own unique characteristics and patterns.
Exactly. And recognizing the type of reaction can help you predict the products and understand the overall process.
It's like having a roadmap for the reaction.
Exactly. And finally, the professor stresses the importance of understanding the driving forces behind chemical reactions.
Driving forces.
Yeah. These are the factors that determine whether a reaction will occur spontaneously or not.
So what are some examples of these driving forces?
Well, one is the formation of a gas.
Okay, so if a reaction produces a gas, it's more likely to happen.
Exactly. Another is the formation of a precipitate.
A precipitate.
Yeah, that's an insoluble solid that forms when two solutions are mixed.
Oh, I remember that from our earlier discussion about electrolytes.
Exactly. And a third driving force is the transfer of electrons.
So reactions that involve the movement of electrons are also more likely to occur.
Precisely. And understanding these driving forces can help you predict whether a reaction will occur and what the products will be.
It's like having a crystal ball for chemistry.
Exactly. And with practice and a solid understanding of the underlying principles, students can approach chemical reactions with confidence and even a sense of excitement.
I like that.
Yeah.
Because chemistry is all about exploring the amazing transformations that matter can undergo.
It's a truly fascinating field, and I hope that our discussion today has inspired our listeners to embrace the challenges and discover the wonders of grade 12 chemistry.
Me too. And before we wrap up, I'd love to leave our listeners with a final thought-provoking question to ponder.
Okay, I'm all ears.
We've talked about how chemistry is all around us, from the food we eat to the air we breathe. But what about the chemistry that's happening beyond our planet?
Beyond our planet.
Yeah,
Well
think about the
said.
vastness of the universe, the countless stars and galaxies out there.
It's mind-boggling.
It is.
Yeah.
And what about the chemistry that's happening on those distant worlds?
Wow, that's a great question. You know, we've discovered evidence of organic molecules in meteorites and in the atmospheres of other planets.
Oh, really? So the building blocks of life might exist beyond Earth.
It's certainly possible, and who knows what other amazing chemical discoveries await us as we continue to explore the universe.
That's an incredible thought to leave our listeners with, the idea that chemistry is not just confined to our planet, but is a fundamental force shaping the entire cosmos.
It's a humbling and awe-inspiring realization.
Yes. So to our listeners out there, keep exploring, keep learning, and never stop asking those big questions about the world around you and beyond.
And remember, chemistry is more than just a subject. It's a way of understanding the universe and our place within it.
That's a great note to end on. So stay tuned for part 3, where we'll wrap up our deep dive into grade 12 chemistry with some final thoughts and insights inspired by this amazing professor's wisdom. Okay, so we're back for the final part of our deep dive into grade 12 chemistry.
Time flies when you're having fun with chemistry, right?
It really does,
Yeah.
and we've covered so much ground in this deep dive.
Yeah, we've explored pretty much every aspect of grade 12 chemistry, from the fundamentals to the challenges to the rewards.
And I feel like we've equipped our listeners with a ton of valuable insights and strategies to help them succeed.
Absolutely. I think they're ready to tackle anything that grade 12 chemistry throws their way.
But before we wrap up, I'd love to leave our listeners with a final thought-provoking question. Something to really spark their curiosity and encourage them to explore chemistry beyond the textbook.
That's a great idea. I'm all for encouraging lifelong learning.
So how about this? We've talked about how chemistry is woven into the fabric of our everyday lives.
Yeah, from the food we eat, to the clothes we wear, to the technology we use.
Exactly. But what about the chemistry that's happening inside each of us?
Inside each of us.
Yeah. Think about the incredible symphony of chemical reactions powering our bodies, our thoughts, even our emotions.
Wow, that's a really interesting perspective. It's like our bodies are these incredible self-regulating chemistry labs, constantly adapting and responding to the world around us.
Exactly. And there's so much we still don't know about the chemistry of life.
It's a field that's constantly evolving with new discoveries being made all the time.
And I think that's what makes chemistry so fascinating, is this endless journey of exploration and discovery.
Absolutely. And it's a journey that we can all be a part of.
So to our listeners out there, as you embark on your grade 12 chemistry journey, remember to stay curious, stay engaged, and never stop asking those why and how questions.
Because that's how we learn and grow and make new discoveries.
And who knows, Maybe one of you will be the next chemist to make a groundbreaking discovery that changes the world.
Now, that would be amazing.
It would. So keep those chemistry dreams alive and never stop exploring the wonders of this incredible subject.
It's been an absolute pleasure joining you on this deep dive.
Likewise. And to our listeners out there, thanks for tuning in, and we'll see you next time for another deep dive into the world of knowledge.